March 18, 1942. Willow Run, Michigan. Before dawn, the factory is already awake. Floodlights cut through the cold Midwestern darkness, illuminating a building so vast it seems to bend the horizon. Steam rises from exhaust vents along the roofline. Trains rattle on sidings loaded with aluminum, steel, wiring looms, engines, propellers, raw materials feeding a machine that has never existed before. Inside, the noise is constant. Rivet guns chatter like machine gun fire. Overhead, cranes groan as they swing massive wing sections through the air. Conveyor belts creep forward with relentless patience. And standing near the center of it all, coat collar turned up against the draft, is a factory manager who has been told, repeatedly, that what he's trying to do cannot be done. His name is Charles E. Sorensen. To the Army Air Forces, he is not a general. He does not wear a uniform. He has no combat experience, no medals, no rank. What is something the war now desperately needs. An obsessive belief that airplanes can be built like cars. Around him, men and women stream into position along the line. Some are former auto workers. Others were farmers, shop clerks, mechanics only months earlier. Many have never seen an aircraft up close before this job. Yet here they are, preparing to assemble a 4-engine heavy bomber, the Consolidated B-24 Liberator, an aircraft with over 450,000 individual parts. In Europe, German intelligence believes replacing a bomber crew and aircraft takes months, sometimes longer. Losses are tallied, analyzed, celebrated. A raid repelled as a victory assumed to echo into the future. At Willow Run, Sorensen is about to make that assumption meaningless. He walks the line slowly, eyes tracking movement, stopping occasionally to speak to foremen. The Liberator fuselage in front of him is incomplete. Bare aluminum skin, ribs exposed, wiring still hanging loose, but it is moving, always moving. That, more than anything else, is his obsession. In traditional aircraft factories, planes are built in place. Skilled craftsmen move around a stationary airframe. Adjustments are made by hand. Each aircraft becomes, in effect, a unique machine. Sorensen hates this. He believes uniqueness is inefficiency. And inefficiency, in a war measured by attrition, is death. Months earlier, when the Army first approached Ford to build bombers, many within the aviation industry laughed. Auto executives building precision aircraft? Impossible. Airplanes weren't Model TS. They couldn't be rushed down a line without sacrificing quality. The tolerances were too tight. The systems too complex. Even within Ford, engineers pushed back. The Liberator's design itself resisted standardization. Components didn't align cleanly. Subassemblies varied. Suppliers delivered parts that almost fit, but not quite. Sorensen responded the only way he knew how. He tore the process apart. He broke the bomber down into modules: nose, center fuselage, wings, tail. Each redesigned so parts would fit the same way every time. He demanded suppliers adhere to exact tolerances or be replaced. He introduced gauges, jigs, and fixtures borrowed from automotive production and adapted them for aircraft assembly. Most controversially, he put the bomber on a moving line. At first, it was chaos. Workers fell behind. Parts piled up. Misalignments multiplied. Early Liberators rolled off the line incomplete, requiring extensive rework. Army inspectors complained. Reports flowed back to Washington warning that Ford was failing. Sorensen did not stop the line. He sped it up. Mistakes, he believed, were not proof the system was wrong. They were proof the system wasn't finished yet. Every error exposed a bottleneck. Every delay revealed a flaw that could be engineered out. He reorganized stations, simplified tasks, reduced the number of skilled operations required at each point so that a worker could be trained in days instead of years. If a step took too long, he split it into two. If a part caused delays, he redesigned the interface. Above the floor, chalkboards tracked output in brutal clarity. How many fuselages entered? How many completed sections exited? How many hours lost to stoppages? The numbers climbed slowly at first. One bomber every few days, then one a day, then one every shift. By late 1942, German U-boats still prowled the Atlantic. Luftwaffe fighters still tore into bomber streams over Europe. Crews still failed to return. But something had changed. Back at Willow Run, the line no longer paused when a bomber was finished. It simply kept moving. By the winter of 1942, that movement had become hypnotic. Inside Willow Run, the Liberator was no longer treated as an aircraft in the romantic sense. It was a sequence, a progression of stations, each one stripped to its essential function: riveting, wiring, plumbing, engine mounting, control surfaces. Nothing ornamental, nothing optional. If a task did not move the bomber forward, it was eliminated. Charles Sorensen stood on a raised platform overlooking the floor, stopwatch in hand, watching a fuselage section glide past a row of workers installing bulkhead fittings. He did not look at faces. He looked at seconds. If one station took longer than the next, the imbalance rippled backward through the line. Delays multiplied. Output fell, so he adjusted the system again. He brought in time and motion specialists, the same men who had once optimized how fast a worker could install a door on a Ford sedan, and unleashed them on the bomber line. Every movement was measured, every reach shortened. Tools were suspended on retractable cables, so workers didn't waste time bending or walking. Parts were delivered exactly where they were needed, exactly when they were needed. This was not craftsmanship. It was control velocity. Many aviation traditionalists were horrified. Aircraft, they argued, demanded care, judgment, intuition. Sorensen countered with results. Army inspectors, initially skeptical, began to notice something unsettling. The bombers coming off the Ford line were not worse than those built by traditional methods. They were more consistent. Panels aligned the same way every time. Wiring harnesses followed identical routes. Maintenance crews in England would later remark that Ford-built Liberators felt predictable, almost standardized in a way aircraft had never been before. In Germany, intelligence officers studying aerial reconnaissance photos did not yet understand what they were seeing. Bomber losses were tallied meticulously. A raid over Bremen cost 30 aircraft. Another over Kiel cost 40. The assumption, deeply ingrained in Luftwaffe planning, was that replacement rates were limited by skilled labor, specialized tooling, and time. Those assumptions were correct, just not for the enemy they were fighting. At Willow Run, Sorensen faced a different enemy: scale. The plan itself was unfinished when production began. Rain leaked through the roof. Snow blew through open walls. Workers wore coats at their stations in winter. Conveyors had to be rerouted weekly as new sections of the building came online. The Liberator's design fought standardization at every step. Early production models varied. Engineering changes arrived constantly from consolidated in the Army Air Forces. New radios, new gun mounts, revised fuel systems. Each change threatened to slow the line. Sorensen responded by isolating chaos. He created modification zones at the end of the line. Instead of stopping production to incorporate changes immediately, bombers would roll out in a baseline configuration and be upgraded afterward. The line never stopped. Adaptation happened downstream. It was a radical idea. Freeze the process, not the design. By mid-1943, the consequences reached Europe. German flak units reported bomber streams growing thicker. Fighter pilots reported shooting down aircraft only to encounter fresh formations days later. Luftwaffe planners noticed a disturbing pattern. Losses no longer translated into reduced pressure. In one internal report, a German analyst noted that American bomber strength appeared insensitive to attrition. At Willow Run, that insensitivity was deliberate. The line accelerated again. Sorensen demanded tighter coordination with suppliers. Entire subassemblies, cockpit modules, wing sections arrived pre-built, ready to bolt on. Rail cars rolled directly into plant. Aluminum arrived in coils and left as aircraft. Training pipelines expanded. Workers were rotated to prevent fatigue. Women made up an increasing share of the workforce, mastering tasks once considered too technical. Mistakes still happened, but the system absorbed them. The numbers told the story. One Liberator every 4 hours, then every 2, then, briefly, every 63 minutes. When the 1,000th bomber rolled off the line, there was no ceremony, no speeches, The line did not stop. The next fuselage was already approaching. In England, air crews noticed something else. Serial numbers that climbed with unsettling speed. Maintenance depots filled with replacement aircraft. Squadrons rotated losses without standing down. For the first time in the war, air power became arithmetic. German commanders still believed in tactical solutions, new interceptors, heavier guns, improved formations. What they did not yet grasp was that the battlefield had shifted. They were no longer fighting planes. They were fighting a factory. And that factory did not sleep. March 6, 1943. Schweinfurt, Germany. From the ground, the sky looks diseased. Contrails scar the blue in thick white bands, overlapping and crossing until the air itself seems stitched together. The distant rumble arrives first. Low, steady, mechanical. Then the formations appear. Boxes of B-17s and B-24s, layered in altitude. Sunlight flashing off aluminum skins. German flak crews stare upward, counting almost instinctively. They lose track before the bombers do. Inside a Luftwaffe operations bunker, a duty officer marks the raid with greased pencil strokes across a wall map. He estimates numbers based on radar plots, visual reports, radio chatter. The figures are large, but not unprecedented. Losses will be inflicted. They always are. What the map does not show is Willow Run. In Berlin, the intelligence summaries still rely on pre-war logic. Aircraft production is assumed to scale slowly, constrained by skilled labor and hand-built processes. Even optimistic estimates place American bomber output at levels that should be vulnerable to sustained attrition. The numbers from the front do not fit. After Schweinfurt, German fighter units claim dozens of bombers destroyed. Gun camera footage confirms kills. Wreckage burns across the countryside. And yet, days later, new formations appear, unchanged in size, unchanged in confidence. Reports circulate quietly. Bomber losses are not reducing raid frequency. Replacement aircraft are arriving faster than anticipated. At Willow Run, Sorensen receives no such reports. He does not need them. He measures progress by a different metric. Tack time, the precise interval between completed bombers. The plant is now machine learning itself. Supervisors adjust shifts based on bottlenecks detected the day before. If a rivet supply runs low, a runner is dispatched before the shortage reaches a line. If a tool breaks, a replacement is already staged. Sorensen institutes visual controls, boards, lights, signals that show line health at a glance. Red means stop. Green means flow. The goal is uninterrupted motion. When the line does stop, and it does briefly, it restarts with minimal ceremony. No investigation committees. No paperwork. Fix the problem. Move on. The effect compounds. By mid-1943, Willow Run alone is producing more heavy bombers than entire Axis nations. In Germany, this reality filters upward slowly, diluted by disbelief. General Oberst Hans Jeschneck, chief of the Luftwaffe General Staff, notes in private correspondence that American losses appear operationally tolerable. That phrase, operationally tolerable, carries a dangerous implication. That destruction is no longer decisive. For decades, air power theory assumed fragility. Aircraft were expensive. Crews were irreplaceable. Industrial bases could be worn down. Willow Run breaks that assumption. Each bomber destroyed over Europe has already been replaced, sometimes before the loss report is even filed. Back in Michigan, the human cost of this pace is real. 12-hour shifts. Noise that never stops. The smell of oil, hot metal, and solvent hanging in the air. Workers develop routines to cope. Counting steps, humming songs, marking time by the position of the sun through high factory windows. Sorensen walks the floor late at night, unannounced. He stops beside a young woman installing control cables, watches her hands move with practiced speed. "How long have you been doing this?" he asks. 3 weeks, she replies without looking up. 3 weeks. In pre-war aviation, that would have been unthinkable. Here, it is the point. Training is modular. Tasks are narrow. Mastery comes quickly. The system does not rely on individual brilliance. It relies on reliability. The Germans, meanwhile, still search for a decisive technical counter. New fighters, new rockets, new tactics. Each promises salvation. None address the real problem. In August 1943, another raid hits Schweinfurt. Losses are severe on both sides. The Americans pull back temporarily, adjust tactics, then return. And when they do, the formations are larger. German intelligence officers finally adjust their estimates upward, then upward again. Each revision lagged reality by months. One capture report, circulated quietly within the OKL, uses an unsettling phrase. Enemy production appears elastic. Elastic. Stretch it and it snaps back. Willow Run continues to stretch it. By late 1943, the plant's output becomes a strategic constant. Planners in Washington assume its numbers the way they assume tides or daylight. Operations are scheduled around expected replacements. Attrition becomes a line item. And somewhere over Europe, a German pilot lines up a Liberator in his gun sight, fires, and watches it fall. He does not know that another is already rolling off a line thousands of miles away. Engines mounted, controls tested, paint drying. The count continues. October 14th, 1943. 25,000 feet above Schweinfurt, Germany. Inside AB, 24 Liberator named Lucky Lady. The air is thin and sharp with cordite. The aircraft shutters as flak burst nearby. Black puff that blossom and vanish in seconds. The waist gunner, Sergeant Paul Henson, keeps firing even as fragments rattle against the fuselage like gravel thrown at a tin roof. You can feel it now, the scale of it. Not one bomber, not a squadron, but a system in motion. When Lucky Lady turns for home, two positions in the formation are empty. Flames mark where they were. Back in England, clerks update chalkboards. Losses are recorded, crews reassigned, replacement aircraft scheduled. There is grief. There's always grief, but there is no pause. At Willow Run, no one knows the name Lucky Lady. They know only serial numbers. The factory floor hums with controlled urgency. By now, the line has been shortened, refined, optimized. Parts arrive pre-kit. Everything needed for a specific station packed together in advance. Workers no longer hunt for components. They reach, install, and move on. Charles Sorensen stands with a stopwatch beside the line, timing transitions. He has done this his entire life. In car plants, in foundries, in places where speed meant survival in a competitive market. Now speed means something else entirely. He notes a 3-minute delay at Station 42. The issue is minor, a misaligned jig. By the next shift, it is gone. This is not innovation in the heroic sense. No lone genius sketching blueprints by lamplight. This is engineering as discipline, as repetition, as relentless correction. And it terrifies German planners more than any secret weapon. In Berlin, Reichsmarshal Hermann Göring demands explanations. How can the Americans sustain this? How can they keep sending more bombers after losses like Schweinfurt? Subordinates offer partial truths. The United States has vast resources. It has distance. It has allies. But none of these fully explain the numbers. The real answer, that American industry has transformed aircraft into consumables, remains unspoken. By late 1943, German production strains under contradictory demands. Aircraft designs change midstream. Factories are bombed, dispersed, rebuilt. Skilled labor is stretched thin. Each new aircraft requires specialized workers, months of training, custom tooling. In contrast, Willow Run's Liberators are nearly interchangeable. A wing built on Monday fits a fuselage completed on Friday. Engines from different suppliers bolt into the same mounts. Variance is the enemy, and variance has been hunted down. The impact reaches the front in subtle ways. Luftwaffe pilots begin to notice patterns. Formations no longer thin out over time. Escorts grow more numerous. Bombers fly deeper, stay longer, return sooner. A German intelligence officer writes in his diary that the enemy appears indifferent to losses. That is not entirely true. Losses matter. Every crew lost is a blow, but the system absorbs the shock without collapsing. At Willow Run, production crosses a psychological threshold, one bomber every 90 minutes. then every 75. The factory celebrates quietly. No banners, no speeches. The line simply moves faster. Sorensen is already focused on the next target. He authorizes changes others would hesitate to make. Entire sequences are reordered. Tasks once done in series are done in parallel. Inspection, traditionally a final step, is distributed throughout the line, so defects are caught instantly. Quality does not drop. It rises. German analysts studying wreckage are puzzled. American bombers are not crude. They are consistent. Repairs are easier. Damage tolerance improves. This was not a design miracle. It is a production one. In early 1944, a German officer touring a damaged airfield in France watches a captured B-24 being towed away for examination. He runs a gloved hand along the fuselage, noting the uniform rivet lines, the standardized fittings. "This was built like a truck," he mutters. He means it as an insult. It is anything but, because trucks are meant to be replaced. By spring, Willow Run reaches its most astonishing milestone, one complete liberator every 63 minutes. Faster than Germany can count them. Faster than intelligence can revise estimates. Faster than flak and fighters can make a dent. Somewhere in Europe, German commanders finally begin to grasp the truth. Not all at once, but piece by piece. They are not fighting an air force. They are fighting a factory. January 11th, 1944. Berlin, Air Ministry Headquarters. Snow presses against the tall windows as Major General Joseph Kamhuber studies the latest loss tables. Columns of numbers run down the page. German interceptors lost, American bombers destroyed, sorties flown. He traces one column with a pencil, then stops. The ratio is wrong. It has been wrong for months. Every doctrine he helped build, night fighters, controlled interception zones, radar-guided ambushes, assumes a basic truth: attrition works. Bleed the enemy long enough, and the offensive collapses. But the American columns do not shrink. They grow. Kamhuber sets the pencil down. He knows now what few will say aloud. Strategy has become irrelevant. The enemy's replacement rate has exceeded the defender's ability to destroy. This realization arrives not as a dramatic revelation, but as a quiet, suffocating certainty. Across the Atlantic, Willow Run is operating at full wartime rhythm. The factory no longer feels extraordinary to the men and women inside it. It feels routine. Whistles mark shift changes. Lunch pails sit beneath workbenches. Someone has chalked a cartoon on a steel column. An exaggerated bomber with wings stretching to the ceiling. The line never stops. Each aircraft moves forward with mechanical indifference. Nose section, bomb bay, wing join, electrical, engines, final assembly, rollout. What Sorensen has created is not just speed. It is predictability. The Army Air Forces plan entire campaigns around it. At 8th Air Force Headquarters in High Wycombe, planners pencil in losses with brutal honesty. 30 bombers lost? 40? The numbers are grim, but manageable. Replacement aircraft are already scheduled. Crews rotate. Training pipelines expand. For the first time in history, air war is governed by industrial math. Germany cannot compete with this math. Even when German factories surge, under Albert Speer's rationalization efforts, they cannot standardize fast enough. Models proliferate. Variants multiply. Each improvement complicates production instead of simplifying it. American bombers, by contrast, change slowly and deliberately. Any modification must justify its impact on the line. If it disrupts flow, it waits. This discipline frustrates designers and saves the war. By early 1944, intelligence reports reach Berlin confirming what pilots already know. Destroyed bomber formations reappear within days, sometimes within hours. A squadron wiped out over Bremen is replaced by another flying the same route the following week. Same altitude, same timing, same tactics. From the ground, it feels like fighting a tide. In March, a German flak officer in the Ruhr writes home that shooting down bombers has become a task without consequence. At Willow Run, the consequences are measured in seconds shaved from assembly steps. Sorensen walks the floor with younger engineers who ask him how this became possible, how a single factory now outproduces entire nations. He gives them no grand speech. Control the process, he says. Everything else follows. That philosophy extends beyond Michigan. Plants across the United States adopt the same methods. Boeing, Douglas, North American. Each applies lessons learned from the automotive world. Interchangeable parts, flow control, time motion studies. But Willow Run remains a symbol. German reconnaissance photographs the massive roof again and again. Analysts measure shadows to estimate interior space. They calculate output based on square footage. They are always wrong. They cannot see the discipline inside, the culture, the refusal to slow down. By the time Allied bombers escort themselves deep into Germany with long-range P-51 Mustangs, the outcome is already determined. Air superiority is no longer a battle. It is a condition. Factories like Willow Run have made it permanent. Late in the war, captured German officers are shown production films. They watch liberators roll off the line in uninterrupted sequence. Some shake their heads. Others stare in silence. One officer finally speaks. "We thought you would tire," he says, "that your people would lose interest." The American officer escorting him does not reply, because interest had nothing to do with it. This was systems engineering, industrial momentum, a civilian way of war. And once it began, it could not be stopped. April 25th, 1944, 26,000 feet above Augsburg, Germany. The B-24 formation stretches from horizon to horizon, a staggered grid of aluminum shapes cutting through thin spring cloud. Engines drone in steady unison. Inside the lead aircraft, First Lieutenant Harold Jensen checks his gauges without urgency. Everything is normal, almost boring. That is what frightens the German pilots below. Hauptmann Erich Muller pushes his Messerschmitt Bf 109 into a climbing turn, sunlight flashing across his canopy. He has intercepted American bombers since 1942. He knows their formations. He knows their guns. But he has never seen this many. They keep coming. Even as flak bursts bloom among the boxes, more bombers slide into place, closing gaps with mechanical precision. Where one aircraft falls away trailing smoke, another occupies its space minutes later. Muller fires, brakes, dives. He scores hits, sees panels tear loose, watches one Liberator tip and spin. Yet the formation does not thin. It advances. On the ground, factory sirens wail. Workers run for shelters already damaged by earlier raids. The bombers arrive exactly on schedule, payloads intact. 4 German defenders. It is no longer a question of courage or skill. It is arithmetic, and they're losing. Back in the United States, Willow Run produces its 4,000th bomber without ceremony. There is no celebration on the floor, no banners. The line keeps moving. To stop now would be unthinkable. Sorensen receives a short note from Washington, congratulating the plant on record output. He folds it, places it in his pocket, and returns to the floor. There are bottlenecks to address. Always, he has built something that cannot pause without consequences. In Germany, those consequences become unmistakable by summer. Fighter units are exhausted. Replacement pilots arrive with fewer hours. Fuel shortages ground aircraft that survive combat. Even when bombers are destroyed, the victory feels hollow. They return anyway. German intelligence finally updates its estimates. The Americans are not replacing losses monthly or weekly. They are replacing them daily. At High Wycombe, air planners speak openly about inevitable dominance. They plan raids not around what they can afford to lose, but around how quickly they can overwhelm defenses. The bomber stream becomes continuous. Daylight raids press deeper. Night raids overlap. Repair crews in German cities work under fire, knowing tomorrow will bring the same. In September 1944, a captured Luftwaffe officer is questioned by Allied intelligence. He is asked when he believed the air war was lost. He does not hesitate. "When your bombers did not stop," he says, "after Schweinfurt, after Regensburg, when we destroyed them and they returned larger." That return is Willow Run's signature. German analysts never identify Sorensen by name. They speak of American industrial leadership, of automobile methods, of assembly line warfare, but the effect is personal to those who face it. Pilots watch the sky fill. Anti-aircraft cruise fire until barrels glow red. Commanders file reports that grow more desperate in tone. Nothing changes the numbers. By early 1945, Allied bombers fly with impunity. Escorts roam freely. Fuel depots burn. Rail yards vanish. The German war economy collapses not in a single moment, but under relentless repetition. And repetition is the product of factories. When the war ends, Willow Run does not close immediately. The line slows, then stops. Silence settles over a space once defined by motion. Thousands of workers walk out for the last time, scarcely aware of the scale of what they have done. They did not design strategies. They did not fly missions. They made the missions inevitable. Years later, historians will argue about tactics, commanders, and aircraft performance. But buried in reports and production charts is a simpler truth. Germany could count bombs destroyed. It could not count how many would replace them, because one factory manager had turned production itself into a weapon and taught it to fire endlessly.